Okay, so what we are doing today is working with the sine, cosine, and sine sum or difference formulas. Okay, now I'm going to show you how this formula works, and then I'm going to do a little, and then I'm just going to touch upon a little bit of background information. Okay, now let's pretend you have, let's start with the sine one. Okay, so the first thing I want you to notice is look at how this says plus minus and this says plus minus. Okay, and then I want you to look at how this says plus minus, however this says minus plus. Okay, perfect. Thank you for letting me know you can see my screen. Okay, so we're talking about the sine and cosine sum or difference formulas today. Okay, and we're going to be working with these formulas, and I want to, like I said, I want to show you how do these formulas work, and then I'll do a little bit of background explaining. Okay, now, I want you to first notice how this says plus minus and this says plus minus. However, cosine formula says plus minus here. However, it says minus plus there. Okay. Now, what that means is that if this is plus, this is going to mirror, okay, the same thing. It's going to be plus. And vice versa. If this were a minus, this would also be minus. Okay. However, on top here, what this is saying is that if this is plus, this is going to be opposite. That's minus. And vice versa. If this is minus, then that's going to be plus. Okay? Now, let's see this in action over here. Okay? Let's pretend it's actually really easy to use. Okay? So let's pretend that we have sine of 45 minus 15. Okay? Let's start easy. If this is minus, this is going to be minus. Okay? And again, this is 45, 15, 45, 15. Okay, UV. Okay. Same deal here. I wish they used AB instead of UV, because sometimes people they're scrolling too fast with their eyeballs and they mistaken the U's for the V's and vice versa, but A and B's are more distinguishable. Anyways, now let's do the same thing here. Let's pretend this said 45 minus 15. Okay, remember, if this is minus here for the cosine formula, this is plus. Okay, and I'm just going to write 45, 15, 45, 15. Okay, and then just look up these unit circle values. Okay, now, typically what I like to do, let me back up and give you a little bit of background information. Typically, what I like to do with these is explain how the formulas came to be. Okay, now this proof is actually, it's based on the Pythagorean theorem. Okay, it's based on the Pythagorean theorem. Okay, and it gets a little bit gnarly in all honesty. Okay, it gets a little bit gnarly. Now there are proofs on YouTube. You can literally type in proof of sine sum or difference, and I've came across, I forgot which exact videos, but I've came across some videos that do a pretty decent job of explaining. So if you are curious about how these came to be, okay, then you can just look up the proof on YouTube. Now, the proof, cos, sine. Okay, let me move this up here. Okay, the proof will only explain cosine sum or difference. And then sine sum or difference is basically a knockoff version of the cosine. Basically, what I meant to say is that once you know cosine sum or difference, then you just do a couple tweaks and it'll produce the sine sum or difference. But the key is to get to cosine sum or difference. So again, if you're curious on how to get on how this came to be, type in proof of cosine sum or difference form on YouTube. There's quite a few great videos on explaining that. So now, if you are truly interested, okay, if you're truly interested in how this came to be, okay, just shoot me a message anytime, an email, and then maybe I can show you which YouTube video I particularly like in their explanation, or I can just explain it to you. Okay, but as of right now, in the interest of time, I'm just going to give you these formulas. Okay, so let's see this in action. However, okay, so let's start with this. Okay, cosine of 15. Okay, boom, boom, and let's go like that. Okay, cosine of 15. Now I'm going to pull up the unit circle here. Let me share my screen. Okay, let me pull up my unit circle. Where is it? Documents. Boom. Nope, it's under downloads. Okay, unit circle updated. Okay, let me rotate this around. Okay, now look at how they rewrote cosine of 15. They rewrote, first of all, I hope we can agree that 45 minus 30 equals to 15. Okay? How come they chose to write it as 45 minus 30? Okay? Why didn't they choose to write it as, I don't know, 20 minus 5? Okay? Why not write 20 here and 5 there? Because 20 minus 5 is 15. The reason they did not do 20 minus 5 is because, do you see a 20 degree on the unit circle? Okay, there is no 20 degree on the unit circle. Okay, do you see a 5 degree on the unit circle? Okay, you don't. So you can choose 20 minus 5. However, it's not going to be as convenient because the unit circle does not have 20 and 5 degrees written on it. Okay, so we want to make our lives easier, so we're going to choose unit circle values. That's why they chose 45 minus 30. Okay, that's why they chose 45 minus 30. Okay, now sometimes the unit circle values that you choose are going to be different than the unit circle values that someone else in the class chooses. That's fine. Okay, you're still going to get the same answer. Okay, so once you figure out these two values, your life becomes really easy. Then what you do, okay, is just plug it in the formula. We're going to use cosine. We're going to use this one right here. Okay, so I'm going to put this aside. Okay, and again, remember cosine, the signs, if this is minus, when you apply the formula, it's going to be plus. It's always opposite. And I'm referring right now, okay, I'm referring to this right here. These are always going to be opposites. Okay, and that's what you get when you apply the formula. Okay, now again, just look this up on the unit circle. Okay, and these are going to line up. Okay, boom, 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 boom. Just look it up on the unit circle. Okay, now when you simplify it, that's what you get. Okay, and you just leave it like that. Okay, you just leave it like that. Now let me look at some problems here. Now sometimes what they're gonna do, you're gonna see some problems where you're gonna go backwards. They're gonna go backwards. They're gonna start you off with this bottom blue, okay, and then you work your way up to this blue, and then you finalize with that blue right there. Okay, just a heads up. All right. Okay. Now, what I was gonna say was, let's see, I think I might as well just talk about tangent too. Okay, I might as well just talk about tangent too. So let me copy and paste the tangent formula. I actually was not going to talk about tangent, but I might as well. Okay, there's a tangent sum and difference. Okay, and it is right here. Copy and paste that. Put it right here, and let's do another one. Let's get this out the way. Okay, and let's put tangent right here. Let me dip that in blue to be consistent. Boom. Not quite the shade of blue I wanted. Okay, I'm just going to keep it in green. Screw it. Okay, then I'm going to change this to green too, just to be consistent, which means then I have to change this to green. Okay, so let's go ahead and look at tangent here. Let's see, I got a tangent example somewhere here. Okay. Maybe I don't have a tangent example. Let me see if they have. Huh, interesting. They didn't use a tangent for. They didn't use a. They didn't. There's not a tangent example, but it's not a big deal. Okay, we can easily create one right here. So let's bring back tangent here. Okay, bring back tangent, and let's look right here. Now, so let's pretend it said tangent of. Let's say you had a problem that said tangent of 15. Okay, I'm going to rewrite that as tangent of 45 minus 30. Okay, and then I'm going to follow the formula. Okay, remember this is u, this is v. Okay, and in this case, remember, look right here. This case, the signs match. So if it's plus here, it's plus here. However, on the bottom, it is the opposite. If it's plus here, it's minus here, and vice versa. Okay, so watch how I do this. This is going to equal to tangent of 45, okay, minus tangent of 30, all right, over 1 plus tangent of 45 minus, whoops, not minus, times tangent of 30. Okay? Tangent of 45 is going to be, where's my unit circle at? Tangent of 45 is going to be 1. Okay? This is going to equal to 1 minus tangent of 30 is root 3 over 3 over 1 plus tangent of 45 is 1 and tangent of 30 is root 3 over 3. Okay. Now, believe it or not, that's the only new part. Okay. From here on out is just simplification. Okay. And unfortunately, simplification is where, in tangent's case, the simplification for the sine cosine ones are easy. The simplification for the tangent ones are, I'm not gonna lie, it's kind of annoying. Okay. So this is gonna equal to 1 minus root 3 over 3 over 1 plus root 3 over 3. Okay? All right. I am going to, while you work, okay, while you work on, I mean, should I do it now? Let me see how long this video is so far. Yeah, I'm gonna cut this short right now. I'm gonna while you guys work on the next problems, I'm going to show you the steps to this, okay? Because I don't want to make this video super long, okay? Um, you know what? I'm just gonna do this real quick, okay? I'm gonna rewrite the 1 as 3 over 3, okay? I'm gonna rewrite this one as 3 over 3, okay? And then I'm going to get 3 minus root 3 over 3 over 3 plus root 3 over 3. Okay? And I'm going to side hustle this. Maybe I don't even need to side hustle this. Okay? This is going to be 3 minus root 3 over 3. Actually, I can write it right here. I can save myself some space here. Okay? And this is going to be divided by 3 plus root 3 over 3. Remember, we're going to keep change flip. 3 minus root 3 over 3 times 3 over 3 plus root 3. Okay, these 3's cancel, and you are left with 3 minus root 3 over 3 plus root 3. Okay, and then this is taking you back to a lesson from October. You got to multiply by the conjugates because you don't want roots on the bottom. Okay, you do not want roots on the bottom. And you are going to get 9 minus 6 root 3 plus 3 over 9 minus 3, which gives you 12 minus 6 root 3 over 6, which gives you 2 minus root 3, okay, over 1. Okay, and that's your final answer. So let's be honest with ourselves, okay? The simplification process, even though it was old stuff from before, let's just be honest, and I'm gonna admit at least, okay, maybe you disagree, which is fine. It's gnarly, okay? It's gnarly. Everything, this yellow highlight here, okay? It's just, I wouldn't even say gnarly, because gnarly means it's super challenging. I just think it's just tedious, okay? It's just tedious. And you're going to come across some situations where it's going to be, you're going to come across some situations where it is going to be, I mean, this kind of worked out that it was a nice clean 1. What if this was a root 3? Okay. What if that was a root 3? Okay. All right. That's actually not too bad, because then all you got to do, then you just got to multiply. Remember, you want to get the denominators to be the same. So you just put this over 3 and slap on a 3 there. Okay, so you just basically add 2 blue highlights right here. And you do the same thing for the bottom. And then you can combine the top. Okay, and everything else is the same thing. Okay, but just to give you a heads up of different scenarios you might encounter. Okay, folks, anyhow, I don't want you to get too caught up in this yellow highlight. I want you to pay closer attention to the green boxes, okay, because that's more important. That's a new thing, okay? All right, folks, I want you guys to use these concepts and do the next problems.